Today we'll discuss to you about the radius of curvature. Radius of curvature, guys, plays a lot of roles in the field of engineering, especially in civil engineering, involving topics when it comes to beam deflections, solving for stresses in beams, flexural stresses in beams, etc. So to begin with, let's say we have a curve defined by the equation y as a function of x. Okay? Now, kung tatanong ka, ba't may radius, wala namang circle. Actually, along the curve, guys, there is what we call the osculating circle. Osculating circle means it changes its radius from time to time. So here in this case, at this specific point, may circle yan dyan. Okay? Wherein, nandito yung center niya. So of course, here, may circle din. Kung saan naka-concave yung curve, andun yung osculating circle. Kung dito yung curve, of course, ang circle, andito. Now, paano ma-derive yung radius of curvature na yan? Of course, we have this differential arc length ds. Okay? So, from this point up to this point, actually, this is an exaggerated drawing. Yung point na to, tsaka yung point na to is almost magkadikit lang yan. Okay? Now, if you will move this point up to that point, it will subtend an angle which what we call d theta. Okay? Why d theta? Because actually, this is infinitesimally small. Okay? So, ds is just equal to what? Again, from the formula, S, which is arc length, is defined by the equation R times theta. So, for here in this case, ds is the differential length. So, ds is just equal to what? The rho times d theta. Okay, for most cases, guys, or in most cases, guys, rho, or radius of curvature, is defined by the variable rho. Okay? Now, yung goal lang natin is to compute for the formula for this radius of curvature. So, rho therefore is just ds over d theta. Now, in calculus, we have this what we call the chain rule. What is that? You are allowed to multiply a certain variable equation into a function which is equivalent to 1 or unity. Here in this case, I will multiply dx over dx. Okay? It's just as if I'm multiplying 1. Okay? Now, paano gagawin? Ano yung chain rule? Yung gawin mo, yung dx na yan, lilipat mo sa denominator ni ds. That is dx. Okay? How about this d theta? Lipat mo dun sa dx. So in short, ds over dx times dx over d theta. This will be our governing equation. This is equation 1. Now, alam mo na ito, yung ds over dx. ds over dx is what? This is actually the length of curve, which we already derived in our previous video. So, ds over dx is what? That is just the square root of 1 plus dy over dx squared. Baka malit ka ba't nandito si dx? Actually, yung dx na yan, pwede mo ilipat doon and integrate. Now, we already have this equation. Okay? So, this will become our equation 2, which will be substituted later in our equation 1. Yung goal natin ngayon is to find this dx over d theta. So, paano makuha yan? Kaya again, i-zoom natin ito. Okay? This is d theta. Right? But makakonfuse ka where saan galing yung d theta. Actually, if this is d theta, this is also d theta. Okay? So this is dy, this is dx, and this is ds. Now, tangent theta is just equal to the slope. Okay? That is rise over run, which is dy over dx Now, what if we're gonna take the first derivative of this equation with respect to x? What will happen? The derivative of tangent theta with respect to x is what? That is just secant squared theta. Okay? D theta over dx. Okay? Equal to what? The derivative of dy over dx is what? That is actually the second derivative. Or simply y double prime. So, d squared y over dx squared. Or again, y double prime. So, now, secant squared theta d theta over dx is equal to d squared y over dx squared. Now, lipat ko yung secant squared theta dito, d theta over dx is just what? D squared y over dx squared over secant squared theta. Now, yung goal ko ngayon is dx over d theta, hindi d theta over dx. So, gawin ko, I'll just take its reciprocal. So, taking its reciprocal, dx over d theta is what? That is just secant squared theta over d squared y over dx squared. Now, ano yung secant squared theta? Okay? From our previous video, already computed or resolved what is equivalent to this trigonometric function. So, what is that? Actually, this is just what? This is just tangent squared theta plus 1 or 1 plus tangent squared theta. So, substituting dx over d theta is just what? 1 plus tangent squared theta over d squared y over dx squared. Now, what is this tangent theta? Actually, yun na siya. Tangent theta is just the slope of the line of the first derivative of the function. So again, dx over d theta is just 1 plus dy over dx, that is tangent theta, squared over d squared y over dx squared. And this becomes our equation number 3. Okay? Now, finally, substitute. Equation 2 and 3 to equation number 1. Okay? Substitute this equation 3 and equation 2 into that equation 1. This gives us ds over dx times dx over d theta. Okay? Value of ds over dx is what? That is just the square root of 1 plus dy over dx squared. Okay? Times, what is dx over d theta? That is just 1 plus dy over dx squared over d squared y over dx squared. Now, what can you notice? Actually, we have the same base, but different exponents. Okay? We can express it into its exponential form. That is 1 plus dy over dx squared. Okay? 1/2 means that certain function has an exponent of, square root means that certain function has an exponent of 1/2. Okay? Times this one. 1 plus dy over dx squared. Okay? Of course, this numerator has an exponent of 1 divided by d squared y over dx squared. So, same base, what will happen to the exponent? If you're multiplying functions or exponential functions having the same base, you'll just need to add up their exponents. So 1 half plus 1, that is 1, and 1 half, or simply 3 halves. So your final equation is what? That is just rho is equal to 1 plus dy over dx squared raised to 3 halves all over d squared y over dx squared. Or simply, rho is just 1 plus y prime squared raised to 3 halves all over y double prime. And this gives us the equation for the radius of curvature. Smooth.